Hi everyone, this is Mr. Cervone. Welcome to my math channel. In today's lesson, we will be learning about congruent triangle proofs. So let's get started with the following problem. If segment AB and segment CD bisect each other at point M as shown in the figure below, why must it be true that triangle AMD is congruent to triangle BMC? Well, what can we say about the fact that segment AB and segment CD bisect each other at point M? Well, in that case, we can say that point M is the midpoint of segment AB and segment CD, respectively. Well, if M is the midpoint of those two segments, respectively, then we can also conclude that segment AM and NB must be congruent. And similarly, we can also say that segment DM and MC are congruent as well. Now, our goal here is to somehow determine if triangle AMD is congruent to triangle BMC. And how do we do that? We want to think about one of the postulates that we developed during one of our previous lessons. Basically, the postulates are the SAS postulate. Basically, if you have two sides and the included angle of one triangle that are congruent to two sides and the included angle of another triangle, then the triangles are congruent. Then we have the ASA postulate, which is similar to SAS, but in this case, the sides have to be included in the angles. And finally, for the SSS postulates, if three sides of one triangle are congruent to three sides of another triangle, then the triangles are congruent. So to solve the do now, we want to use one of these postulates. So which postulate would be best to use in this case? Well, here if we look at this diagram here, we don't know if segment AD and CB are congruent. But do we know anything else? Well, the fact that we have segment AB and CD intersecting at point M, that shows that we have vertical angles here. And these vertical angles must be congruent. So therefore, angle AMD is congruent to angle BMC. Now we have all the information needed to show that the two triangles are congruent. So basically here we have a side and a side here, and we have the angle that is in between congruent to the two sides of the other triangle and the angle that is in between. Thus, we can say that triangle AMD is congruent to triangle BMC because of the SAS postulate. So what we just did here is actually a proof pertaining to congruent triangles. So if we converted this into a statement reason table, it would look like as follows. So the statement reason table would be first step, segment AB and segment CD bisect each other at M, or point M, which is the given. The second step, we specify that point M is the midpoint of segment AB and CD. Well, that's because of the definition of a segment bisector. Because of that, we can conclude that segment AB is congruent to segment MB due to the definition of a midpoint, and also segment DM is congruent to segment MC because of the same reason, the definition of a midpoint. Then we conclude that angle AMD is congruent to angle BMC because we know that all vertical angles are congruent. And finally, we know triangle AMD is congruent to triangle BMC because of the SAS postulate. So let's take this a step further. Let's say at this point, we wanted to continue with the proof and also prove that segment AD is parallel to segment CB. How would you prove this? Well, we know that the triangles are congruent. Therefore, we know that by corresponding parts, also any corresponding angle and any corresponding side must be congruent as well. For example, we know that angle A and angle B are congruent. So let's write that in our proof. Well, now that we know that angle A and B are congruent because of the corresponding parts of congruent triangles are congruent, what else do we notice here? Well, we notice here that we have two lines cut by a transversal, and the transversal in this case will be line AB. So it does create alternate interior angles and they're congruent. So therefore, we know that segment AD and CB must be parallel. So in the statement reason table, we would simply write that segment AD is parallel to segment CB because if two lines are cut by transversal and alternate interior angles are congruent, then the two lines are parallel. So that's basically how we perform a congruent triangle proof. And in proving triangles congruent, we want to make use of those three postulates that I mentioned earlier in this YouTube video, namely the ASA postulate, the SAS postulate, or the SSS postulate. So let's look at another problem. Let's say with the following diagram, you're given that angle 1 is congruent to angle 4. You're also given that angle CAB is congruent to angle DBA. How would you prove that triangle ABD is congruent to triangle BAC? At this point, you can pause the video and try to prove this. So the first thing you want to do before even starting the statement reason table is to denote the givens in the diagram as shown now. So our goal is to prove that triangle ABD, as shown in the figure here, is congruent to triangle BAC. So let's get started with the statement reason table. And what we can do here is to cite the second given first. Why am I citing the second given first? Well, it will be apparent in a bit. Once we cited the second given, we can now use the segment addition postulate and specify what angle CAB and angle DBA are composed of. Basically, we can say that angle CAB is congruent to angle 1 plus angle 2 because of the segment addition postulate. And similarly, we know that angle DBA is congruent to angle 3 plus angle 4 because of the same reason. Now that we have these parts of the angles specified here in steps 2 and 3, we can substitute them into step 1 and conclude that angle 1 plus angle 2 is congruent to angle 3 plus angle 4. Then we can write that angle 1 and angle 4 are congruent. And now if we look at step 4, we can subtract angle 1 and 4 from the previous step. And now we know that angle 2 and angle 3 must be congruent as well, as you can see in the diagram. So let's analyze these triangles now. If we look at triangle ABD closely, well, we know that this triangle is composed of this angle 2 over here that I'm going to highlight, okay? And we know that it is composed of angle ABD or DBA, which is over here, right? Now let's look at the other triangle. Now in the other triangle, we can see that that is composed of angle 3 that we have over here that I'm highlighting in the statement reason table. And it's composed of the other angle, which is angle CAB that I'm highlighting here. So if we look at this, we actually do have an angle that is congruent to an angle in the other triangle. And in step 6, we have the same thing, that another angle or a second angle is congruent to the second angle of the other triangle. Now that is still not sufficient to prove these two triangles congruent. So at this point, we actually need another side to prove the triangles congruent. If we knew that another angle was congruent, that is still not sufficient to prove the triangles congruent. And indeed, we do know that the third angles must be congruent from the AA postulate. But that lesson is reserved from another YouTube video. So let's think about this. Which other side do we know for sure is congruent in one triangle to the other triangle? Well, if we look at both triangles, we know that segment AB over here is congruent to segment AB in the other triangle. So basically, these two triangles are overlapping and both share the same segment AB. So we must write that in our statement reason table. So therefore, we know that segment AB is congruent to itself because of the reflexive property. And there you go. Now we have another side available here. So now we can prove the triangles congruent because of the ASA postulate. Okay, so we know that the angles are congruent and the side that is included or in between those angles is congruent to the side that is included in the other angles in the other triangle. Therefore, we know that triangle ABD is congruent to triangle BAC because of the ASA postulate. So this is basically the proof for this particular problem. And that's basically it also for today's lesson. Okay, so today we learned how to prove triangles congruent using either the ASA postulate, the SSS postulate, or the SAS postulate. I hope you enjoyed this video. Again, thank you for watching and have a wonderful day.